Hi students, today we will discuss about the data types. So when you are trying to use any variable, you need to first specify what kind of data type it is. So when we consider any variable, first I need to specify what type of data so that the memory can be allocated in the system and the values will be stored in a particular variable. Okay. So basically, data types are of four types. The first one is the integer, and the next is the float. The third one is the character, and then we have a double data type. So there are basically four different data types. These four are called as a primitive data type. Okay. Like each and every data type can hold a signed as well as the unsigned numbers, which means the signed negative value as well as the positive value. So that the signed values are nothing but you can hold the negative values also. Unsigned means it can hold only the positive number. That is the basic difference between the signed and unsigned. Similarly, a float variable can hold a signed as well as the unsigned number. The difference between the integer and float. The integer will hold only the whole numbers. The float can hold the decimal point. Okay, so whenever you are trying to hold some 3.14, say for example 5 value is 3.14, then I need to declare that variable as the float data type. Okay, and then the next one is the double. So precision, when a float is declared, if I want to go for more accurate value, so instead of giving a 3.14, I want to hold a 3.12789 0. So if I want to go beyond the 6 precision, then I need to declare my data type as a double. So a float data type can handle only 6 precision after the dot, that is after the decimal point. But the double data type can go up to 14. So you can hold 14 digits after the decimal point. So when you need a more accurate result, you can go for using a double. Okay. And the next data type is the character. Suppose when you are trying to hold a character, when you want to get the input as a character, then I need to declare that as a char. So these four are the basic keywords which will be used for the primitive data type. Okay. The next is the qualifiers. So based on this qualifier, the data type of the memory allocated for the data types can be extended or minimized. Say there are four qualifiers are there. The first one is the size, the second one is the sign, the third one is the constant, and the fourth qualifier is the volatile. So there are four basic qualifiers: size, signed, constant, and volatile. If you consider the size qualifier, if I gave a short int before the integer, if I mention short, which means that in general, if integer data type hold 2 bytes, means it will try to restrict only 8 bit, so that 1 byte of information alone it can be able to handle. Okay. And when I want to extend the data type, say for an example, if I mention long int, then the twice of the integer will be allocated for the data type. So I can either extend the data type or I can minimize the data type based on the size qualifier. We will see this in few forthcoming classes. And we have a signed data types, either as I said in the earlier, like signed or unsigned. So if you are want to hold the negative values, you need to give signed integer, signed int, and the variable name, so that it will be taking negative values. Suppose if you are declaring unsigned int, then it will hold only the positive value. It will not allocate, it will not get any negative value in it. So it restricts. Okay. So the signed or unsigned qualifier will restrict the positive or negative information. Signed means it will allow the positive. By default, signed is the signed data type will be allowed, which means you can get the negative values. suppose if you want to restrict it to only positive informations you want to get, positive value alone you want to get, means you need to declare the unsigned int. Okay. And the next qualifier is the constant. So constant is a keyword. So when I give constant int a equal to 10, so that 10 will not be changed in your program. So always it will kept as a constant. We will not able to change that value. That is nothing but the constant qualifier. The other one is the volatile. So volatile is nothing but suppose in the previous case constant, we are not going to allow a value to be modified. But the volatile, when I give volatile integer, the outside program can hold the control to change the value. So when I want to exclusively change the value outside, then I can give volatile int. So that the inner program can't able to modify, but we can create some interrupt outside so that it will be modified. So these four are the basic qualifiers. During your due courses, you can try to learn more about it. Okay. So we'll move on to the first data type. The data types in general, it will be classified in the four categories like integer and character, float and double. So you can see we are having the variable types of signed and then unsigned. Okay, so there are two qualifiers, as we said, either it may be signed or unsigned. So first we'll discuss about the signed variable. So the keyword basically we are going to use for the character data type, we need to use the keyword char, and then the byte allocated for that is going to be 1 byte, which means 8 bit. Okay, and then you can see the range. Range varies from -128 to plus 128. Say for an example, if my n value is 2, not 2, say for an example 3 if I have. So 2 to the power of 3, which means 8. So 2 to the power of 8. So which means that I can able to hold all the, no, sorry, 2 to the power of 3. So if it is 2 to the power of 3 means 8 informations, that is 0 to 8 you can able to hold. So in general, if it is assigned, I can able to hold the negative as well as the positive number. So if it is a 8 in 8 value means first 4 numbers are nothing but negative numbers. So first half of it. So first 4 will be a negative number. The remaining 4 is going to be the positive number. So 2 to the power of, which means like 8 informations means say from -4 and -3 -2 -1. So these are the negative numbers, and positive numbers are nothing but 0. The next 4 are positive numbers, 0, 1 and 2, then 3. So if my n size is going to be 3 means I can able to hold the value starting from -4 to n minus 1 of positive number. So in general we can say it is nothing but 2 power n, which means that 2 power, this is nothing but 4. 4 means 2 power 2, right? So 2 power n minus 1. Say now we are considering the n value as 3. So 2 to the power of n is nothing but 3. So 3 minus 1, 2. So 2 to the power of 2, which is nothing but a 4. So the negative number of 2 power n minus 1, 2. The positive number of 2 power n minus 1, we are not getting 4, right? So it will be subtracted by 1. So in general, the numbers can vary from minus 2 power n minus 1 to 2 to the power of n minus 1 minus 1. So up to this, any value can be holded. Say for an example here, the character of 1 byte. So which means that n is going to be 8 bit. So if n is going to be 8 bit means minus 2 power 8 minus 1, that is minus 2 power 7 to 2 power 7 minus 1. So minus 128 to plus 127 can be holded in the character data type. So if you are not clear, we will discuss in the next class. Fine. So now a character 2 to the power of minus 2 power 7 means, just check in your system so that you can get the value as 128. So 2 power 7 means you will get 128, and then minus 128 to plus 128 minus 1, that is maybe 127. Now hope you have understood. Similarly, for the integer data type, we need to go for the keyword called int, and then the data type, that is byte holded by the integer, is going to be 2 bytes, and the range is from 2 to the power of 15, that is 16 minus 1. So 2 power 15 to 2 power 15 minus 1. Okay, so that range is in this range. And then the format specifier for the integer data type is percentage %d. Okay, for the character it's a percentage %c, for the integer it's going to be a percentage %d. And the next one is the float data type. For the float data type, it is going to hold 4 bytes, which means 2 to the power of 4 into 8, that is 32. So 2 power 32 bits can be possible in this float data type. And one more thing is, float data type can hold 6 precision. After the decimal, it can able to hold only 6 digit. Okay. And this is the range of the float, and the percentage %f is the specifier you can need to utilize. And when we go for the double, it's the extended version of the float, and the double data type can able to hold twice of the float data type, so that the precision for the double is going to be 14. Okay, so after decimal you can hold 14 digits. And this is the range of float data double data type. And when you are trying to use your variable as a double, you need to use the format specifier as a percentage %lf. Okay, so percentage %lf is meant for the double data type. And the long integer, this is also a extended version of the int. Okay, so it's twice of your byte, which may be used in a integer. So now you can see here it is a 2, now this is 4. And the data type of the format specifier for the long integer is a percentage %ld, and this is the range. So it is nothing but 2 to the power of 31, that is minus 2 to the power of 31 to plus 2 to the power of 31 minus 1. Okay. So that is the overall range of the long integer. Similarly, the signed integers are there. So in that, what you want to do is you need to exclusively specify the unsigned. So the keyword you need to use unsigned character, so that it can accept only the positive integer. Here you can see the negative numbers are going to be accepted, but here it can access only positive. So it ranges 0 to, if it is a n is 3 means 0 to 7. So which means n minus 1 informations can be holded. So 0 to, now it is 8 bit means 2 to the power of 8, which is nothing but 256. So from 0 you are including, so that's why it takes from 0 to 255. And then the character data type is percentage %c. So you need to use a format specifier as percentage %c. And the integer is nothing but now it's an unsigned integer. So if it is an unsigned integer, you can get only the positive numbers. Okay, and the format specifier is nothing but percentage %u. So when you are declared your variable as an unsigned int, then you need to give percentage %u. not the percentage. Okay, so just have it in your mind. If it is an unsigned integer, we need to use a percentage. Mostly when you are using a memory, at that time we may be using an unsigned int, so that the address reference can be taken, the address of the system. Okay, or a buffer, so where a port address, so some address if you want to use, then at that situation we will be using the percentage u, so that it will try to have a only positive numbers. Okay, and the other one is the unsigned long integer. This will try to have a 4 byte as the signed only, but it takes all the positive numbers. And the format specifier is percentage %. The next one is the long double. For long double is nothing but 10 bytes can be allocated, so which means 2 to the power of 80, that is 10 into 8, because byte is nothing but 8 bit, so 10 into 8, 80 bit can be holded in the unsigned long double. Okay, so that the format specifier is nothing but capital L. So percentage capital L. Here you can see this is a small l. This should be a capital L. Okay, and we will discuss one by one. So the data type constants, in which the integer data types always uses the whole number. So we can always represent only the whole number here. So that's why if you see in this example, no need now. We'll take only the stdio.h, which means the standard input output header file will be included, as because of we are using a printf statement. Okay, so we need to include this. This is always necessary in every C program. You should not forget this. Okay. And then integer main. Then we have a integer c equal to 5. So what I'm doing is I'm creating a variable c in the form of integer data type and assigning the value as 5 in c. Okay. So what happened now? The c holds the 5, and there is no any fractional part, so you should not give a point 0 or something. So it should be only dozen, only a whole number. And then we have a integer variables can hold only integer values. Okay, so this can hold only integer value. The keyword used for the data integer data type is int, and then memory allocated for the integer is 2 byte in general. Suppose if I am trying to give a long int, means it will try to allocate 4 bytes, as the 32-bit system can support to extend the gigabytes. And then you can also use the qualifiers like a signed, unsigned, and short, long before your integer data type. I think we already discussed this. So short int, long int, signed int, unsigned int. So based on that qualifiers, the memory can be extended or shrink. Okay. So the short means it will try to reduce, long means it will try to extend. Signed and unsigned can able to handle the positive as well as the negative values. And these are some of the examples for the integer. So you can give 34,012, it's a positive number. 0 is also your integer data type, and minus values also be the integer. What is the restriction here? If I give unsigned integer, then this negative value will not be permitted. 0 can be permitted, not the negative. Okay. So you will have only the positive numbers. Hope you can understand the integer data type. Now we will move on to the other program. Now in the previous case we are trying to assign the value directly. Now we will have one simple example how to get the input from the command prompt. So a user, if he wish to pass some value, means I need to get the input from the user. So for that we need to use the scanf statement. So by default the scanf is a keyword. So you can use this keyword in order to get something from the command prompt or from the user. And it has the open bracket because it is a function, predefined function. So it has the open bracket in which within double quotes you can try to give a data type. So now here we are going to declare a variable as an integer. So that's why we are taking a percentage d ampersand a. So that what happened? It will try to get the value from the user and then allocate the memory as 2 bytes, and then 2 byte of memory will be allocated for a variable. Then the value which is fetched from the command prompt will be stored in a. This ampersand is always mandatory in the scanf statement. So whenever you use a scanf statement, please keep in your mind you need to provide a address reference. This address of A is always necessary. Okay, don't forget to give a address. You need to always give the address. Then only the memory will be allocated for the defined variable. Okay. And then like a simple print statement, you can give a percentage d and the variable a, so that it prints the value present in that variable wherever you are providing the format specifier. So now what is the output for this statement? The output is nothing but integer that you have entered is, say for an example, if I am trying to give a value as 10 during the runtime, then I will get my output integer that you have entered as 10. The next example is one of the example for the float data type. So the float data type can hold the float variable, which means that I am trying to provide some real numbers, that is decimal numbers. So I will declare a variable float a, and I am just using a scanf percentage f for the float data type and then ampersand a. Okay, so now what happened? This a variable will act as a float data type, and the float data type can have a fractional part, and the precision of that float data type is going to be 6 digit. Always float variable can hold the real numbers. Okay, so just forget about this line. I can have a keyword float and it can allocate 4 bytes of memory, and some of the examples are 5.6, 3.075 and 3.14756. But whenever I'm going for more than one let's say for an example here, after the precision, after the decimal, I'm going beyond 6. So in this time, the float variable can hold only 3.14756. It will not hold 12 because the precision can handle only 6 digit after the decimal. Okay. So in that time, we need to move on to the double data type. Okay. So the double data type can handle the precision of 14 digit. So it's also basic type of a float only, but it can handle more than 6 precisions. Okay, so and it will go up to only 14 digits, and this can handle the integer values as well as you can hold the float, you can also hold the double. Okay, so instead of float, what I want to give, you need to declare the variable as double devo u b l e. Instead of float, you need to give a data type as float here. Okay, and then during the scanf statement, instead of f, I want to give percentage lf, and the rest are same as your float. Okay, the keyword you want to use is nothing but double, and then it can handle 8 bytes. If you are trying to go for a long double, then it can go for 10 bytes. Okay, and also based on the qualifiers, it can able to shrink or extend. Fine. So this is the double data type, and the next data type is the character data type, where the character data type can handle only one character at a time. So 1 byte of memory will be allocated, and the keyword is nothing but a char. So character C, it means that I'm going to declare a C as a character, and the format specifier is nothing but a percentage C ampersand, that is address of the variable name. And when you are trying to give a percentage C, it can able to get only the character. Even though if you pass 10, this will be considered as character only. It will not be a number. Okay, so it will be folded as a ASCII format. Hope you have understood the basic data types of integer, float, double and character. Thank you.